Right, section 6.2, we get into talking about how we can use proportions to solve side lengths in geometry. Right, so the scale drawing is a drawing that is the same shape as the object it represents. And the scale is a ratio that describes how the dimensions of a drawing are related. To the actual dimension of the object. So like think of maps, like the map of the country or the world or the United States. A map is much smaller than the actual size, so it's drawn to scale. Some additional properties of proportions is the reciprocal property, and that says if A over B is equal to C over D, then B over A is equal to D over C. So essentially, it's flipping both fractions. So when you flip them, they're still equal to each other. If you interchange the means of a proportion, then you form another true proportion. So if A over B equals C over D, then A over C equals B over D. So you flip the means. So notice the means, again, are B and C. If you flip B and C, it's still going to be equal. Number 4 is in a proportion. If you add the value of each ratio's denominator to its numerator, then they form another true proportion. So if A over B equals C over D, then A plus B over B equals C plus D over D. So when you add up the top and the bottom and put over the bottom, like A plus B over B, it's equal to C plus D over D. And those are just some properties that we should know. Okay, example 1 says, in the diagram, AC over DF is equal to BC over EF. Write 4 true proportions. So AC over DF equals BC over EF. So AC is 12. So 12 over DF. DF is 18. So we have 12 over 18 equals BC is 9. And EF is X. So 12 over 18 equals 9 over X. Okay, that's the first proportion. The second one would be if you do the reciprocal property. So that'll be if you flip them. So we would do 18 over 12 is equal to X over 9. Number 3 is interchanging the means. So we interchange the means, which in this case are 18 and 9. So we will get 12 over 9 is equal to 18 over X. That will be number 3, interchanging the means. And the last one is adding the numerator and denominator. So we would get 12 plus 18 over 18 equals 9 plus X over X. So these would be our 4 proportions. Okay, one is where you flip the top and the bottom, one is where you flip around the means, and one is where you add the top and the bottom. Example 2, use the proportions with geometric figures. In the diagram, JL over LH equals JK over KJ. Find JH and JL. So JL is this part right here. So if the whole thing is X, that blue part is going to be X minus 2. Okay, so JL is X minus 2. So if we zoom out, JL over LH is X minus 2 over 2 equals JK is 15 and KG is 5. So we end up with X minus 2 over 2 equals 15 over 5. So to solve this, we have to do cross multiplication. So if we cross multiply, we would get 5 times x minus 2 equals 2 times 15. 2 times 15 is 30. And the other side is 5x minus 10. And then we got to solve. So we would add 10 to get 5x equals 40. And then divide by 5. So x equals 8. So we found x. So since x equals 8, how big is JH? JH equals 8. And then JL is x minus 2. So it's 8 minus 2, which means JL is equal to 6. So JH and JL are 8 and 6. Okay. In the checkpoint, it says, in example 1, find the value of x. So example 1 was 12 over 18 equals 9 over x. So 12 over 18 equals 9 over x. And we're going to solve for x, so we have to cross multiply. 12 times x equals 9 times 18. So we end up with 12x equals 9 times 18 is 162. And then we divide by 12 to get x equals 162 divided by 12 is 13.5. So we set up our proportion and we cross multiply to get x. In example 2, KL over GH equals JK over JG. Find GH. So we look at example 2. KL is 12. Okay, and I'm getting that from up here. KL is 12. So it's 12 over GH. Let's call GH Y. So say 12 over Y equals JK. And we said JK is 15. And JG, let me change colors. J to G is 20. So it'll be 15 over 20. And then we got to cross multiply. So it's 15y equals 12 times 20. So 15y equals 12 times 20 is 240. And then we divide by 15. Y equals 240 over 15, which is 16. So y is 16. And again, we got that from cross multiplying. Okay, now we get into the scale part. So the length of the key in the scale drawing is 7 centimeters. The length of the actual key is 4 centimeters. What is the scale of the drawing? So to find a scale, we want to write the ratio of model over actual. And then rewrite the ratio so that there is a 1 for the numerator or the denominator. So when making a scale, we take the smaller number and make that your value 1. So again, we have model over actual. That's what we go by. So the model, in this case, is the scale drawing, and that is 7. Okay, the actual key is 4. So we have 7 centimeters over 4 centimeters. So what we want to do is look at the smaller number. The smaller number is 4. We want to change 4 into 1 to make our scale. To change 4 into 1, we have to divide by 4. So we end up with 1.75 over 1. That's what the scale is, 1.75 to 1. Because when we're doing a scale, like a map or a scale of a building, and you make a smaller building, we generally will make it over 1 or have a 1 in that scale. So 1.75 over 1. And it's model over actual. So in checkpoint, it says, in example 3, suppose the length of the key in the drawing is 6 meters. Find the new scale of the drawing. So the scale drawing, they're saying, is 6 meters. We want to find the new scale of the drawing. So again, we are going model over actual. So they're saying the model in the scale drawing is 6 meters, and the actual one is still 4 centimeters. So this is where it gets tricky. Do you see that meters and centimeters are not the same? So what we want to do is change the meters into centimeters. So there are 100 centimeters in a meter. So that means this is really 600 centimeters over 4 centimeters. Because we want to have the same scale, so we want to make sure they're both in centimeters. So 600 centimeters over 4 centimeters. And then now what we want to do is change the bottom into a 1. So again, we would divide by 4. We would have a 1 on the bottom. And 600 divided by 4 is 150. So now the scale is 150 to 1. That's just what we're going to find in the scale. Okay, in example 4, it says the scale of the map at the right is 1 inch for every 8 miles. So 1 inch is 8 miles. Okay, find the actual distance from Westbrook to Cooley. So what we have to do is measure the distance from Westbrook to Cooley. So we're going to measure from here to here, and then here to here. So if we measure it, we're still using model over actual. So the model is 1 inch. The actual distance is 8 miles. So 1 inch for every 8 miles. If you measure in the model, when you measure this out, you would get roughly 1.25 inches. Okay, so if you have a ruler, you'd measure that. And when you do that, you should get roughly 1.25 inches. So that's the model part, 1.25 inches. We want to find out what is the actual distance, so we're trying to find x. And x is the actual distance in miles. So we cross multiply and we get x equals, 1x equals 8 times 1.25. So x equals 8 times 1.25 is 10. So on the map, it's 1.25 inches, but it's actually 10 miles in real life if you had to drive it. Okay, checkpoint 4. It says the two landmarks are 130 miles from each other. The landmarks are 6.5 inches apart on a map. Find the scale. So we have to do model over actual. So in the model, the landmarks are 6.5 inches apart. In real life, they're 130 miles. So we're just trying to find the scale. So what does 1 inch represent? So we have to turn the top into 1 inch by dividing by 6.5. 6.5 divided by 6.5 is 1 inch, and 130 divided by 6.5 is 20 miles. So the scale for this map would mean 1 inch is equal to 20 miles in real life. Okay, and then we have our last example down here. It says you buy a 3D scale model of the sun sphere in Knoxville, Tennessee. The actual building is 266 feet tall. That's the actual building. Your model is 20 inches tall. And the diameter of the dome on your scale model is 5.6. So first, let's do model over actual. What is the diameter of the actual dome? So we know that the model in the dome is 20 inches. Your model is 20 inches tall. 20 inches tall. And we know that the actual height is 266 feet. So this is for the height. And then for the diameter, they tell us that in the scale, the diameter is 5.6 inches. We want to find out how many feet this is in diameter in real life. So we are going to put 5.6 over x, because 5.6 is the model, x is what we're trying to find out. So when we cross multiply, we get 20x equals 5.6 times 266. 5.6 times 266 is 1,489.6. And then we divide by 20. So x equals 1,489.6 divided by 20 is 74.48 feet. So the actual diameter is 74.48 feet. Again, so we took the model over actual height, and then we set it equal to the model over actual diameter of the dome. And then we cross multiply. The last question says, how many times as tall as your model is the actual building? So you know how many times as tall. So if you take the model, what do you got to multiply it by? So if we know that the actual building is 266 feet tall, we want to divide that by how tall the model is. So we want to change these into the same distance. So one's feet, one's inches. We're just going to try to find out what do we get when we divide them. So first, let's change the feet to inches by multiplying by 12. And we get 3,192 over 20. So 3,192 divided by 20 is 159.6. So the actual building is about 160 times bigger than the model. So like picture you have this little model on your table at home. If you took that model times 159.6, that's how big the actual building is.